My name is Venkat Viswanathan. I'm a global partner solutions architect for Databricks, working for AWS. And along with me, I have met a joint customer, Mayur Rajdev. He is head of AI and automation for the Baldwin Group.
I'm Mayur Rajdev. I work at the Baldwin Group, and I head architecture, AI, and automation at Baldwin Group. And we have been using a lot of AWS and Databricks to create our entire extraction pipeline, and I'll be presenting some of those today.
So the way we are going to do today, I'm going to talk about generic architecture principles, and we'll go from customer challenges and so on, like the whole journey. And along with me, Mayur is going to talk about practical scenarios, their organization encountered, how they find solutions, the solution that they are applying. So to start with, this unstructured data is complicated, right? You can see there are various types of unstructured data, complex PDFs. The PDFs may be like OCR non-mission readable PDF or mission readable PDF, or it could be combination of partly mission readable, partly non-mission readable, or it could be multi-columnar PDF data. It is difficult to process those unstructured data. Extracting the information is not easy. Or it could be like forms, like various medical forms or industry-specific forms you may see. Specialist documents like invoices and receipts, identity documents, lending documents, mortgage documents, and the handwriting is another one. Like for healthcare industry, prescription is one of the handwriting, tables and signature. These are some of the complex unstructured data that you commonly see. Mayur, do you want to add anything more?
Yeah. So in our so I come from an insurance industry, right? So the kind of documents we deal with are can be very complicated depending on the kind of policies that you're working with. So one of the things that we've seen is that the complexity in documents is not just from the structural or the semantics of the document. It can also be from the functional aspects of the document. For example, in our industry, when we started looking at different documents, what we figured out is every carrier has a different way in which they share the policy documents with you. I'm specifically taking an example of policy documents. In some cases, we were receiving packaged policy documents, meaning it has auto policy as well, property policy as well, workers' compensation, general liability. Everything is clubbed into one, and everything comes to us as just one document. So that adds a lot of functional complexity into the documents, besides all of the complexities Venkat was talking about.
Thank you, Venkat. And then this data, whether unstructured and structured data, extracting the data is typically done like manually before the generative AI. When you say manually, it's like you need to do a lot of coding exercise, or it could be some human looking at the document and extracting the data. With that, manual extraction, time to market your business solutions, the innovative solution is a big challenge. Scaling this, when you start getting tons and tons of data and extracting this manually is going to be, it's not easy to scale. And at a global level with multiple languages, finding resources and scaling, multilingual support is very, very difficult to find. PI, PHI security, when you do manual extraction, the leakage of PI, PHI is quite possible, and it is expensive. The human engineering involvement in doing this extraction is going to cost a lot of money, and it is also decreases employee productivity before you even start doing the application. Extracting this data, and it takes about, let's say, 60 to 70% of your time. You're not going to see the productivity that you're looking for, and the output can be inconsistent because it's like when human involved, there's going to be prone to error. What you see, what they see, so you need to have several checks and balances to validate this data to make sure that you got accuracy, and continuous training is something. Mayur, want to elaborate?
So one more thing I want to add here is there are basically two types of extraction approaches we went through. When we started looking into documents within insurance industry, there are certain standardized documents that are like Accord forms. I don't know how many are from insurance industry here, but there are certain standard forms which don't change much. Like you have Accord forms, even invoices, for example. And on the other side, there are documents that vary a lot depending on which carrier you're working with, which state you're working with, which product you're working with. There is a lot of variations. An example would be, Nationwide, for example, will call the owner of the policy, they will call them as insured. Versus, if you take the same policy from State Farm, they will call that person as policy holder. So the variations are extremely large, not in just the terminology, but also the kind of coverages and everything. What we figured out is if we try to use ML-based approaches or training-based approaches for these high variable and high variation documents, it becomes extremely difficult for us to scale with them because the variations are coming, that come to you come in very fast, and almost literally you'll have to do continuous training to be able to keep up with those variations that come to you. So we wanted to figure out a way to do extractions without being dependent so much on training. So that's when we kind of switched to a generative AI-based approach, which is relatively, I would say, training-free approach. And I'll talk about how we use that to do extractions from quite complex documents.
Thank you. Just the document processing, stages of document processing, typically it starts with data capture. And then once you capture the data, you want to classify this data. Because there are, like, as Mayur mentioned about package documents, and generally for insurance industry or mortgage or any of those, you're going to see several documents. Could be identity documents, could be pay stubs, and so on. So you want to classify those documents. And then once you classify this document, you want to extract key information from this document. And then you want to enrich those documents. Like when you say enrich, maybe you want to remove PI, PHI information or some toxicity information from there to, like, for an example, like if you are going to do a loan application, maybe you want to remove some of the like biased information. So you want to be ensure that there is no discrimination by gender, by race, or by anything. So removing those kind of things is one type of enrichment. And then after doing all these things, you want to validate, do the validation process and as automate as possible. And based on the threshold, you're going to say, okay, like this is not meeting certain threshold, then you involve human in the loop to look into those and get the data from the human in the loop. Again, put it back into the system. So keep automating as, and eventually you're going to see much lesser number of human involvement in the whole process. Right? And then once you have this data, then you're going to make it ready for your business decisions. It could be for many applications you can build on this
Yeah,
data.
so on this, when we started implementing, I'll start with data capture, right? So what we figured out is we get these documents from lots of different channels, right? So some of these channels could be real-time channels where a customer or our advisor is uploading a document and they expect some kind of a extraction from that document in near real time, which they want to use for their decisioning or something like that. So use cases would be like, somebody uploading a document on a client portal. So those are more like real-time use cases. The other use cases would be more batch, wherein, if we are working with a large number of, vendors and they're sending us documents overnight, or even with carriers, right? So the carriers send us documents overnight, and a lot of these documents land up in our agency management systems, which is basically our system of records. And all of these documents are fed overnight into our extraction pipeline. So how do we handle situations that come in from so many different channels, and how do we kind of put all of those into the extraction pipeline, and so that the extraction pipeline is able to handle all these real-time versus batch scenarios. One more thing I want to add here is, most of the use cases that we saw kind of go through this approach wherein they come, you do a data capture, you might have to do classification because you don't know what the document is. Like in many cases, especially if it's a batch scenario, in batch scenarios, you won't know what the document type is, especially if they don't give you good metadata. In some channels, you get enough metadata so you can easily classify just by the metadata that you receive from the documents. So what we ended up doing is we kind of took a hybrid approach wherein if the metadata is not giving you enough information to be able to classify a document, we basically went inside the document and using generative AI, we did some, we used an approach to basically classify the document using generative AI. And
let's. I mean, we will cover all those things in the coming slides, right? Can we talk about the business decision activities?
Yeah. So the one thing that I want to talk about is, one of the use cases that came to us was ability to compare, these policy documents that are coming in. So let's say there is a new policy document that came in from a prospect. We want to convert them to a customer. So what would you do in a policy document, and how would you talk to a customer? Typically you would take that policy document, you pass it to an advisor goes through that document. In general, what happens is we receive like a set of 10, 15, 20 documents from customers. It takes us like 2-3 days to be able to go through those documents because each of these policy documents could be like 100 pages, 200 pages. So it takes a lot of manual effort on our advisors, for our advisors to be able to understand what is in the policy document. One of the use cases was, can you ingest the policy document and immediately tell the advisor what to talk to the customer about? Like, can you quickly look into the document and extract information from the document, compare it with a baseline? So we created our baselines for every policy type. So auto, commercial property, all these different types, we created separate, baselines on our side within Databricks. Those baselines are compared with the extracted data from the incoming policy. We put it on, compare it with them, and immediately we are able to see the gaps. We are able to figure out, what coverages are not available in this document. What are some of the talking points that the advisors can use to start talking to the prospects in more detail. So those are some of the use cases that were very helpful for us. It kind of helped us to improve our overall, closure of the funnel from the sales lifecycle.
Yeah, thanks so much. So we already covered these customer challenges. Even every stage of the document processing, you can see that there are challenges from data capturing through classification, extraction, enrichment, validation. So would you like to cover the one challenge that you had with S3?
So yeah, in our pipeline, I think if we go to the next one, to the next slide.
There is one. Let's cover that one, maybe when the S3 part data capture. So there are customer challenges. We looked at the complex document processing, how difficult manual process. So AWS and Databricks, as together, we have like architecture tools and technologies. I'd like to go through the architecture, how it better together, like how it works, interoperability, and then we will cover some of the native services, AWS native services that you can use, and how Databricks data intelligence platform can be used. And Mayur will cover how it is applied on the practical application. So Databricks on AWS high-level architecture, as you can see in this one, Databricks is the centerpiece in the AWS ecosystem. The way it works is, you have batch data, it could be files, or it could be from excellent databases, or it could be streaming data. You can ingest the data to S3, then when the data lands in S3, the Databricks has got something called autoloader, which can load the data. You don't need to do anything. It will only process the data only once, no duplication, no missing of files. It's maintaining internally. There is something called RocksDB. It's going to make sure that every file that is ingested is processed by Databricks. Right? So it's an autoloader feature. It's a cloud agnostic platform. So you are not using any AWS specific tools here. It is pure Databricks. So it's abstracting all the underlying information for you. Similarly, like if we have data ingestion for streaming, you can use Kinesis or managed service Kafka or Confluent, any of those streaming, it's all supported in Databricks. So once the Databricks, the autoloader process, typically the data is stored in Delta Lake format. The Delta Lake format is an open table format, and then you can use ML flow for doing like AI, ML, LLM ops, we'll be using that. And you can also integrate with other services, like if you want to use Amazon SageMaker, or you want to connect to Bedrock, you can do that. And there is core AWS services that you can see down, like IAM, CloudFormation, through all the way the security, private link, all those things are, it is solid foundation in which Databricks is built on. Like it is also built on using AWS well-architected framework, and Graviton processor is our differentiation. Like AWS, Databricks on AWS can use the Graviton processor with the Photon engine, which can improve workload efficiency, the cost, price performance. We are having another session on that in the lightning session on cost optimization for AWS and Databricks. We'll be covering over there. Then QuickSight is another one, like you can do visualization. And so that is interoperable. You can Glue catalog is also seamless connectivity is there. And then the next slide, what we see here, it is pretty, here we want to focus more on Databricks platform. Like you can see the foundation, like the data layer is where like you see Delta Lake. The Delta Lake is using a Medallion approach where you ingest raw data, which is bronze, and then you do some sort of enrichment. Then you create extract information, and you create a business domain-specific data, which is called gold standard, right? And then on top of that, you have data and AI governance, where you build catalog, lineages. With the Unity catalog, you can end-to-end, you can get the lineage, right from data ingestion through all the way using LLM applications. You can see that, you can track the drifting, you can also see, okay, which data is used in which notebook, which model. So the complete picture, like 360-degree view of your data and model, everything is can be traced in Unity catalog. And Unity catalog also provides you a capability called delta sharing. So if you want to share the data and the model and the artifacts, you can do that through delta sharing between Databricks or to the outside. And there is a marketplace, so you can also, once you create this product and you want to sell it as a B2B or B2C, you can do that with the marketplace offering. And then Databricks IQ is an intelligence engine which provides for developers an assistant tool where you don't need to really know the full-blown Python code. You can just say in English, plain English, just say, I want to ingest this data using an S3 location. It's going to generate a code for you. And then there is Delta Live Tables for workflow orchestration. It comes with some intelligence tools as well, like Delta Live Tables, machine learning based approach. You can, it's going to use the right resources. And MLOps, Mosaic AI, I think you must have all seen the keynote, so it is expanding. That is also supported. And pretty much then everything else, what you see here is how AWS is integrated with this ecosystem. And here we have the very first, the processing, right? The stages, data capture. So Amazon S3 is the place for data capturing. Like you have scanned documents. It could be from like a typical PDF, JPEG, or capturing through cell phone. Like let's say, like I want to apply for a loan application. I will take, my ID details and so on. I just upload it. Those kind of things. It can be distorted. Could be crumpled pages. It can have some ambient noises, like with some background. So any type of files can come in. So you store this data in S3. S3 is a secured storage central. So it is used as a central repository. Even Databricks Delta Lake is stored in S3. So that is a placeholder for data capturing. So, here.
Yeah, in this, so in our case, when we were using S3, what we figured out is, depending on the channel, so I was talking about different channels, every channel sends you different kind of metadata. And it's very important for you to be able to capture that metadata. What we ended up doing is, for every channel, we ended up defining their own S3 buckets, because that allowed us to then tap into the metadata and all that, and then feed all of that into a centralized S3 bucket. So we kind of started with channel-specific S3 buckets, then moved everything into another centralized S3 bucket. The other thing that some challenges that we faced is, because we were using API gateways from AWS, there are certain size limitations. So some of the files that we were receiving were 100 MB files, and they have, API gateway has an attachment size limitation of 20 MB. So for that also, what we had to do is we kind of created a signed URL for an S3 bucket location, and send the signed URL to the API and then be able to ingest larger documents. So we kind of overcame some of the issues while working through the process with S3, AWS API Gateway, and all the other stack.
Thank you. And then the next one is, you want to automate document processing. Let's say like we talked about distorted files that we embedded PDF, OCR or hybrid OCR type of files. How do you want to eliminate manual extraction? So one of the way you can eliminate manual extraction is to use Amazon TextRact. Amazon TextRact, I'll go through that slide. It's got niche features. Using that, you can extract the information from OCR types. Even like non-OCR also you can use for extracting the data, like mainly in the multi-column complex data types, and the TextRact can be a useful tool. And now with the emergence of generative AI, you can also see that you extract this data in a human readable format in the right way. There are multi-layout and all those things are there. So you extract the data and feed the information to foundation model mainly for pre-training or fine-tuning your model so that you can do better insights. That is one of the use case we see for generative AI, but there are other use cases. And
in our situation, when we used TextRact only for PDFs that were not machine readable, right? So there are, most of the carriers send us machine readable PDFs, so we don't need to necessarily take it through an extraction in TextRact. We just send it through using a Python library and be able to send it into a vector database for vectorization. But some of the documents that we received were hybrid documents, wherein you have not just text PDFs, but you have images embedded in them. So we kind of used a PDF splitter to be able to split the documents and pass the image to TextRact, got the information back, and then sent everything into a vectorization process.
So the TextRact, as I mentioned, this is layout aware is one of the special feature I would say for TextRact. As you can see on the right side, this is the complex document, right? It's one of the sample. You want to extract this data, like it's a multi-column, and you want to extract this data. But if you do not do this layout aware and you just feed and read the document like a PDF reader, what you are going to see is like not column by column, it's going to be like row by row, and your information is not going to look nice. If you feed this data to generative AI to get some context out of it, it's not going to give you a good result, right? With the layout aware, like you can get the title, header, extract the information, and not only that, you can get up to the word, so, and it is a hierarchical way you can get the information. So right information you can get, and you can pass it on to either you can create a business. You can create data warehousing out of it, or you can feed it to generative AI. So you are going to get better results. Right? Then the next feature is about signature detection, mainly for mortgage applications or maybe insurance also, right? Yeah. You want to capture the signatures, and you want to. There are several pages. There will be signatures in multiple pages. You want to auto detect. Okay, this is the signature present in these pages, this signature is not present in the pages. You get those information with accuracy details, so you know whether you need to make a call to the sender for additional document, right? So otherwise, manually going through all the signature detection and saying that after 3 days or after a week, I'm missing this one, then it's going to delay the decision, and probably you're going to lose a customer, right? And then natural language query is another big thing. Like with the complex data that I showed here, let's say that you are not really interested in all the data, you just want to extract only some information. You can do that with the natural language query. You can specific questions you ask. It is not using LLM. It is just purpose-built application AI service. It can extract information using simple natural language query. And then classify is the next one, where once you extract the data using TextRact, now you want to identify what is the document types, right? So classification, With custom classifier, you can, with 20 to 50 documents, if you provide 50 documents, you are going to get accuracy level is going to be, it's going to give you pretty accurate result, right, with 50 documents. So, but you can do training with just 10 to 20 documents, and it can start identifying the document types. So, comprehend can be used if you know the document is going to be coming in a standard format in certain, like for example, driver license. You don't need to even do the training. Use driver license, it can automatically detect and say that it's a driver license. So some of those things, it is already there, but your application, if you know that this is going to be in certain standard format and you train it, it's going to give you the accurate classification. And you can also use for entity extraction, and potentially PI information can also be extracted, and key phrases. These are some of the things, and you can do both real-time or asynchronous processing with classification. Anything you want to add?
Yeah, so we kind of ended up doing a hybrid approach. Again, documents specific to the document, right? If the document is structured and is not changing from one instance to another, Comprehend is a good way to, kind of train the model and be able to use Comprehend to do extractions for those kind of documents. If the document is highly unstructured and there is a lot of variations, that you're receiving, that's when we kind of move towards generative AI-based approach for classification instead of using Comprehend for classification.
Okay, thank you. So we have only 3 minutes. So sensitive data handling is another one. I talked about PII information. You can redact or you can mask this information, and then before sending it to generative AI, that is what we're talking here. And then what is generative AI? There are steps, you can start with zero shot, where you're just asking, okay, give me what are the company's financial risk factors. Like after getting the extracted data, you just give the data and then ask the question. You are going to get a response. That's a response you get. But if you do give, let's say for few shot prompting, you're just giving some sample, and then you ask the question. Now you are going to get the answer with the source, right? Which page 15 contains this information. Then the third one is where like a RAG approach is coming into picture, where you are going to extract the data. Then as Mayur mentioned, like there's some documents can be like 100 pages, hundreds of pages. So you don't want to load the entire document into generative AI and ask questions. So because generally the questions that you ask is going to be there somewhere in the document, right? So you want to get those relevant paragraphs or chunks, and you're going to first do the chunking, and then you're going to store the data in embedded, like which is vectorized in a vector search. And then when you ask prompt is going to convert into vector and look for similarity search, get only the knowledge base that contains this information, and then do generative AI such as summarization or getting information in a concise manner. We have only 1 minute. That is so.
Yeah, I think on this quickly, just to summarize how we used RAG approach to basically do the classification and also extraction. The key thing here was that when we use RAG, we are basically converting everything into vectors. The example that I was giving initially, like somebody calls insured, somebody calls policy owner, somebody calls the same thing as policy holder. Like these are all, when you look at it from a vector index standpoint, the vector indexes of all of these will be very close together. So you don't have to train, once you vectorize all these documents and you're able to create the right prompts for them. And the way we created prompts was by using the taxonomy. So we kind of started defining for every field, we started providing a description for every field. So we created our own taxonomy-based approach where every field that has to be extracted has a description. That description is used to auto-generate prompts, and that's how we were able to kind of create an approach of, prompt-based approach of doing classification and also extractions.
Okay. So with that, this is the reference architecture that you can see using AWS AI services and Databricks. So in the top portion, you can see extracting document use Lambda, and there are a series of Lambdas, right? In between, there is SQS is going to glue together multiple Lambdas, right? And like OCR documents and non-OCR documents, you extract it. And then once you extract the document, you're going to embed it. Embedding, you're going to use Bedrock model for embedding, Bedrock hosted model for embedding, and then for vector store in AWS, AWS native services, you can use either OpenSearch or RDS with the PG vector or DocumentDB or Neptune is for graph-based vectoring. And then once you do that, classification is where, as Mayur mentioned earlier, either you can go with the comprehend or you can go with, for unstructured unknown data, you can also construct a prompt, which is a rule-based, like a taxonomy-based model. You dynamically create a prompt and then you send it to, you do the, you call the LLM for finding what is the classification is all about. And then once you know the classification, you organize your data, and then you extract entity data, extract the actual data, like the whole document data, and then you're going to put it in, once you validate, you're going to put it in DynamoDB. And if the validation fails, then you do augmented AI A2I, which is AWS Amazon service that you can use for human review, and you can validate and update the data, then finally you put it in DynamoDB, right? Once you have all this data in place, what you can do is you can use Databricks as a source of truth, where you can store all this data for using data intelligence, using Mosaic AI, and for batch process, I'm going to show the different architecture, but this can be this is a real-time, this is a real-time AWS Lambda-based approach. And this is for batch, where you are going to see everything can be done with the Databricks data intelligence platform, right? You don't even need to use the Lambdas and so on. And since Databricks is moving more and more towards serverless, is 100% available, you are almost going to get near real-time. So you can eliminate using native services and simplify using Databricks data intelligence platform. Here, this single notebook, like using autoloader, as soon as the data comes in, you are going to extract documents, classify, extract entity. With a single notebook, you can do pretty much. And then you can do the RAG. That part is no change. You can parse chunk documents, do the embedding within using Mosaic model serving. It supports external models and custom models or database foundation models. You can use any of them, and you can use Bedrock. And if you want to use even other services like OpenAI or other hyperscalers or any new model comes in, you can use any of those models, and you can leverage the best models out there. You can do comparison. And finally, the data is put in Delta Lake as like taxonomy data or feature data, classification data. And once you have this data, now this is where you're going to do all the new features that today the Databricks made an announcement. You can build data intelligence on top of this. I think, and then some of the use cases here for generative AI, you can use the chatbot, summarization, extraction, classification, doing content creation. You can do, like, since you have so much data, you can automatically create content, and industry specific, like medical record analysis or translation, localization. With generative AI, language is not a barrier anymore for running your business. So you can go at global scale. This is a little bit more detailed one, where it says how to detect OCR and so on. And this is using AWS Lambda approach. So here we are using S3, Lambda, SQS, SNS to extract, comprehend. Okay. And Mayur already talked about most of them.
I think the only thing I just want to add about this slide is, this is how we were able to kind of create, for every document, we created a taxonomy. And this screen basically shows you how we created the taxonomy. So this is where a business user can go and upload a document type and say, talk about the document, like what this document is, what are some of the key elements that will help you to classify a document. So you just provide a basic description of the document in plain English. And this is what will be used to auto-generate prompts, which will then help you to do extractions and classifications, right? So every field that we want to extract, every, like in case of packaged documents, we were able to explain like what this document is. And once we created this taxonomy, we had the ability to even classify packaged documents. Like if they are a combination of multiple documents, we were able to do that because of the way we created the taxonomy for them.
And then the next one is about classification extraction thing. Same thing, right?
Yeah, this is more like just a view to show how we did the human in the loop validation. So once the extractions were all complete, everything was done. We got confidence scores also. So confidence scores tell us how confident the model is that it is able to extract the information correctly or not. And you can use that as a like a way to pass this information to a human in the loop. If the confidence score is below 80% or some threshold, which you can configure, you'll be able to pass it to a human in the loop, and they'll be able to validate whether the extraction was done correctly or not, and you'll be able to feed it back into the system.
Awesome. I think. Thank you so much. For any questions, you can visit our booth, AWS booth. I will be there, and I'm happy to have detailed conversation. Thank you so much.